Hey everyone, we're going to start a new unit now. This is Miss Williams, and the new unit is going to be on exponents and logs, and this is video 1. The title of the video is Rational Exponents, so you want to make sure you write all that at the top of your page. So the overall view, what we're ultimately trying to do is change powers to roots. A fractional exponent is the same as a rational exponent. So as you can see, the a has an x over y. The x is called the power, and the y, or the denominator, is called the root. So you've heard roots before, square roots, cubed roots, stuff like that. So the number on the outside of a radical symbol is the root, and the number on the inside is called the power. Alright, these can be written two different ways. You can actually write with the power on the inside of the root, where the x is actually right on the a, or you can actually take that x and put it on the outside of the entire quantity. Alright, here's some examples. If you have x to the 2/3, it would be the same thing as the third root of x squared. Another example, what if I don't have a power on the x? Well, we all know if we don't see a power, the power is 1. So the fifth root of x can be rewritten as x to the 1/5. And finally, the one that's the trickiest is when you don't have numbers either places. So exponents, when you don't see them, the power is 1, but a root, if you don't see it, the root is 2. So the square root of x can actually be written as x to the 1/2 power. Alright, before we go any further in this unit, we're going to have to do a quick exponent rules, and hopefully a lot of these are going to be review for you. The first one is negative exponents. What about 5 to the negative 2 power? How could I make that negative 2 be positive? Well, I can just, since 5 to the negative 2 is in the numerator, I can just bring it to the denominator and actually makes the exponent change signs and becomes positive. Same happens if you start with a negative exponent in the denominator. If you just bring that if you bring the base and the exponent to the top, put it in the numerator, it actually makes the exponent become positive. It changes its sign. So here's the actual formula. So make sure you write that on your paper also. And something you might want to remember is upstairs, downstairs. A negative exponent means it's in the wrong place, so you need to put it in the other spot. If it's in the numerator, put it in denominator. If it's in the denominator, put it in the numerator. Okay? Product of powers rules says 2 to the 10th times 2 to the 20th. So 2 to the 10th means I have 10 2's that are being multiplied by each other, and then I have 20 2's that are being multiplied. So that gives me a total of 30 2's that I am multiplying by themselves. Okay, so here's the actual rule. A to the m power times a to the n power is equal to a to the m plus n power. Now remember, this only works if you have the same base. Okay, now we're doing a quotient rule. So if I had if I had 10 3's in the numerator, they're all being multiplied, and I had 4 3's in the denominator, then, we've already done this in the last section, we could cancel out things that match. So that would end up with, after I canceled the ones that matched, I would end up with 6 3's in the numerator. So what am I really doing to those exponents? I'm really just subtracting them. And again, it has to have the same base. If it doesn't have the same base, then you can't do this. What if you have a power of a power rule? So what does this really mean? This really means I have x to the 4th times itself 3 times. So I have x to the 4th times x to the 4th times x to the 4th. Well, how many x's would that totally give me? Well, I can do it quickly by multiplying. I have 3 x to the 4th, so that actually gives me x to the 12th. Alright? So a to the m to the n power is really a to the m times n. Alright? Power to the power, you're going to multiply. What if I have multiple things inside my parentheses? So here it says I have 2 times x to the 4th, and I'm going to do that 5 times. So what I have to remember is that the 5, the exponent on 5, goes to both the 2 and the x to the 4th. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's how I'll get 32. And then 5 times 4 is 20, because I really have 5 sets of x to the 4th. And here's your rule right here. If you have a times b to the m power, all to the nth power, the n gets taken to both the a and the b. Okay? Every base inside the parentheses gets that exponent. It's like distributing. Alright, same would hold true if I had an exponent and a quotient or a division or a fraction inside the parentheses. I'm going to have to remember to give that 5 to both the 3 and the y. Okay, the power to the quotient rule. I accidentally put the rule first, but as you can see, if you have a negative exponent on the outside of the parentheses, negative exponents means they're in the wrong place, so I need to move things. So you can take that -2 and it comes to the 3, and the -2 comes to the y, but now they're both in the wrong place, so I'm going to need to flip those. And the y comes to the top with its squared, and the 3 goes to the bottom with its squared. And anytime you can work out the problem, 3 squared, you know what that is? It's 9. So this really just means y squared over 9. Alright? The rational exponent rule. Now this is what we did at the very beginning, so I'm just reiterating this. So if you have 16 to the 3/4, that really means the 4th root of 16 all to the 3rd power. And you can simplify that and actually get 2 to the 3rd power, and 2 times 2 is 4 times 2 is 8. Alright? What if I wanted to change it from a radical to an exponent? So a to the 1/2 is the same as the square root of a, and a to the 1/n is the same as the nth root of a. Alright, and I talked about this one would be a tricky one at the beginning, so we're just reiterating it here again. 25 to the 1/2 power just means the square root of 25, and hopefully we all remember that the square root of 25 is just 5. Okay, and that's the end of our presentation today. I hope you guys have a good evening, and I will see you soon.